Thank you for the organizers for giving me this opportunity. A special thanks to Dr. Ramani ma'am for
Thank you, sir.
providing me this opportunity to deliver a lecture in this FDP. So today I'm going to talk about AI-enabled sensing and decision making for IoT systems. Okay, let us start with the definition of an IoT. So IoT, you might be knowing, stands for Internet of Things. So the basic definition comes like this: a dynamic global network infrastructure with self-configuring capabilities based on standard and interoperable communication protocols, where physical and virtual things have identities, physical attributes, and virtual personalities, and use intelligent interfaces, and are seamlessly integrated into information network, often communicate data associated with users and their environments. So this is a standard textbook definition of a Internet of Things. So now let us break this definition and we will try to understand what is Internet of Things. The first statement states that it's a dynamic global network infrastructure. So we are going to have a very huge network. It is going to be worldwide and it is going to be a dynamic one. Dynamic one in the sense it keeps on changing. As and when I add nodes, I remove some nodes, it dynamically gets changed. So such a big infrastructure we are going to have in our Internet of Things. So this such a big dynamic network infrastructure is need to have self-configuring capabilities, because it is very difficult. If I want to add a node, if I want to go and do the calibration part, if I want to configure it, it becomes very, very difficult. So it should be in a self-configuring mode. So as soon as I connect a new node into the network, it should get configured. It should get attached to the network so that the data transfer can happen seamlessly. So this is the second important thing with your IoT. And this network, IoT network, should work with some standard and interoperable communication protocols. So there are many communication protocols, wired protocols, wireless protocols. For example, in case of a wired, we have a CAN protocol, control area network, where we try to use, where we try to connect different electronic components via CAN protocol in an automobile system. Same way, we can have something like a UART communication, I2C communication, SPI communication. In terms of wireless communication, we have Bluetooth communication, Zigbee communication, Wi-Fi, WiMAX. So like that, we have different protocols and all are standard protocols. So we can't have the whole world in a same protocol. Some network, some small network can be with Ethernet protocol. Another network might be working with some Wi-Fi protocol. Another network might be working with some Zigbee protocol. So like that, we need to interconnect all these protocols together. So that is why it is called as interoperable communication protocols. It should support standard protocols and also it should support interoperable communication protocols, because we can't have a unified protocol for the entire globe. Right? So we will be having different networks. So all these networks should be interconnected with each other so that they can share the data among each other. So it should have this interoperable communication protocols. And when we connect a node into the IoT network, so these nodes should have identities. Identities as we have a name, right? For us as a human being, we have a name which gives us an identity. Same way, when I have a node, it should have some identity. Usually this identity will be in terms of an IP address. And each node should have some physical attributes, some characteristics. What should be the data rate of transfer? So what should be the size of the data which it is going to transfer? So like that, it should have some physical attributes, and each component should have some virtual personalities too. And it should use intelligent interfaces, and this node should get seamlessly connected to the information network. You should easily get connected to the global network, and you should be able to share the data. So now let us look at this definition one more time. Now we will be able to understand it in a much better way. IoT stands for Internet of Things, which means we are going to have a dynamic global network infrastructure. We are going to have a very big network which is going to be dynamically getting changed, and it will be with self-configuring capabilities. As and when I add a node, I remove a node, what will happen? Automatically it gets self-configured, and it should support standard communication protocols, and also it should work with interoperable communication protocols where physical and virtual things have identities, physical attributes, and virtual personalities. And it uses intelligent interfaces to send the data into the information network. Now, I hope you might be understanding about the definition of this IoT in a better way. There are different applications of an IoT. So this most of you might be knowing. In home, we can use IoT for smart lighting, smart appliances, intrusion detection system, gas and smoke detectors. In case of cities, government is heavily investing on making a city to be a smart city. So in that we can have a smart parking system, smart roads, structural health monitoring, emergency responses can be incorporated. In case of an environment, we can have weather monitoring, air and noise pollution monitoring, forest fire detection, etc. In terms of energy, we can have a smart grids and smart renewable energy systems. In agriculture domain, we can have smart irrigation, greenhouse control effects can be achieved. In industry, we can have a machine diagnosis and prognosis is possible. Indoor air quality monitoring is also possible. In health and life sciences, IoT plays a very major role. Like health and fitness monitoring, we have numerous gadgets as a wearable electronics to measure the blood pressure, heart rate. Different parameters of our human health can be measured using the wearable electronics. In retail and logistics, to have an inventory management system, smart payment, route generation scheduling, fleet tracking, shipment monitoring. So like that, we have enormous applications for an IoT systems. So there are different types of IoT devices available. In case of home appliances, nowadays most of the electronic equipments comes with the CPU. It comes with the controller, which means the data which we try to collect by the device can be easily get connected to your cloud environment. Thereby, we can share the data in a cloud environment. In home appliances, TV, fridge, mobile phones, laptops, so different type of things can be connected. Same way, smartphones, computers can generate huge amount of data and it can be transferred to an internet communication. We have numerous wearable electronic devices. In automobiles, most of the electronic equipments can be automated and it can be controlled. In case of an energy system, either it is a renewable energy system or conventional energy system, we make use of lot of IoT devices there. If for surveillance camera, so surveillance camera feed can be connected to a cloud and it can be monitored from a remote place. Healthcare systems, printers, industrial machines can be controlled, and for retail payments also it is possible to have IoT devices. So these are some of the IoT devices which I quote here. Now let us see what is an IoT device, what it should have and how it should be configured. Before that, let us discuss about research in IoT. Okay, as I said, IoT is a multidisciplinary. It is a multidisciplinary, so you should have a skill set of different specialization. For example, IoT, we need to have some electronic components, right? So a node needs to be designed. So the node, usually it will have a controller, and we will try to connect a lot of sensors, actuators connected to the controller. So we will be having systems and control. So in this area, we can do a lot of research. In systems and control, we can do a lot of research. And in networks, once the data is acquired, how to communicate in a local network, how to send the data to a remote network. So there we have a lot of wired protocols, wireless protocols, how the latency can be reduced, how data rate can be increased, how errors can be minimized. how network congestion can be minimized. So like that, in different aspects in terms of network, we can work in case of your IoT. And since IoT, the nodes are going to acquire the data in a large number. So huge data is going to be acquired, right? So huge data is going to be acquired, and we can do a lot of cloud computing. We can incorporate machine learning algorithms, and we can make the node to be much more smarter in nature. So a machine learning also can be utilized. So if you look at this Venn diagram, you can see that we need to have some knowledge about the hardware, right? So what type of hardware we want to use, how to design the hardware, how to program the hardware, we need to see. Same way, we should have a knowledge on communication aspect, right? So how data can be transferred from one point to another point, and how it can be sent with the minimum latency, with the minimum power, how it can be sent. So in that aspect, we need to have some knowledge about communication. And then we also need to have some knowledge about big data analysis, cloud computing, machine learning. So it becomes a multidisciplinary event. So you have a lot of scope when we talk about research in IoT. So let me talk about machine learning, right? So machine learning is a subset of your artificial intelligence. So first we will try to see what is artificial intelligence. So artificial intelligence means we are going to write a program which can sense, reason, act, and adapt. So ultimately, our artificial intelligence algorithm is going to run in a CPU, computer, right? So we are going to write a program. It is not a conventional program. In a conventional program, what happens? We write a program, it takes some input, it does some processing, it will give an output, right? So there is no intelligence involved there. But here in an artificial intelligence program, we are going to write a program which has some past experience is going to be there with the program. So with the past experience, whatever it gets as an input, so that is sensing part, right? So through sensors, it will get the data. So the current data, and it has a lot of experience added. Based upon this, it will try to reason it, the data, and then it will try to provide an act and adapt to a particular situation. So such a program, we call it as an artificial intelligence program. So what I'm trying to say here is we are going to write a program, so which has some past experience, right? Past experience in the sense, for different inputs, what might be the outputs, how the outputs will be obtained for the different inputs. So such experience already we give it to the program. Now a new input comes. When the new input comes, it takes into consideration that past experience and also the current input. Based upon that, what it is going to do, it is going to make a prediction. So such a program, we call it as artificial intelligence program. So in artificial intelligence, we have a subset called as machine learning. So in machine learning, we are going to write again a program or algorithm whose performance gets improved as they are exposed to more and more data, which means I'm giving more experience to the program. We are incorporating more experience to the program. So as I give more and more exposure to the program, it gains a lot of knowledge. Once it gains a lot of knowledge, then its prediction can be much more valid. So such algorithm is called as a machine learning algorithm, right? In machine learning, we have another subset called as deep learning. So in deep learning, we are going to make use of neural networks. So neural network is nothing but neurons connected in a network fashion. And each neuron will does some functionality, and it will decide whether the information to pass on to the next layer neuron or not, right? So we will be having a multi-layered neural network, which is going to learn from the data, and it is going to keep that as a memory. And then based upon the current input, it is going to make a decision. So such an algorithm, we call it as a deep learning algorithms. So in machine learning, we have three types of learning. One is supervised learning, unsupervised learning, reinforcement learning. So in supervised learning, we will be having both data as well as labels. So using this data and labels, so label is nothing but based upon the information in the data, we give a small label to it, which represents the data, right? So this is a input and this label is an output, right? So we have a data with labels. So we give both these things to a network to learn, model to learn. So after learning, if I give only the data based upon the past experience, what it will do, it will try to predict the label. So such an algorithm, we call it as a supervised learning algorithm. Next, we have unsupervised learning. So in unsupervised learning, we have only the data. So from the data, what the model or algorithm will do is, it will try to find the similarity between the data, or it will try to find the association between the data. Based upon that, it can group the data together. It can form clusters together, right? So thereby it can able to give a classification out of the data. So such an algorithm, we call it as an unsupervised learning algorithm. Then we have a reinforcement learning algorithm where our model does not have any data, it does not have any labels. So what it will do, so it has no past experience has been fed to the model or algorithm. So no learning is there initially to the model. So what it will do, it will try to do some action. For every action, it will either get a reward or a penalty. It will get a reward if its action is going to be good. If it will be penalized if its action is going to be false. So it is going to learn by itself, right? As a child learns how to walk, first it will try to stand, it will fall down, so slowly it will adjust and it will start standing on its own legs. Same way our model will also, what it will do is, it will try to learn on its own by doing some action. So for every action, it will be getting some reward or a penalty, and this information it will try to keep it in its mind. So after some time, if it comes to the same scenario, similar scenario, in that case, what it will do, whatever it has got earlier, whatever it has seen earlier, so based upon that, it will try to make the current decision. So such an algorithm is called as reinforcement learning algorithm. So supervised, we give the experience, past experience to our model to learn. Based upon the past experience and the current input, the model will make a prediction. In case of unsupervised learning, only from data, our model will learn and say that this data and this data are similar in nature. So these two can be grouped together. So like that, it will give a inference. In case of a reinforcement learning, it will learn on its own by performing some action. So these are the major criteria in your, or major types of your machine learning algorithm. Now let us look at the steps involved in machine learning algorithm. So I'm going to especially talk about a image classification scenario. So what is image classification? If I give an image to a model, the model should be in a position to put an appropriate label from a finite set of labels given to it, right? So for example, if I show an image, so if I show this image to my model, okay, so I have a label like man, dog, cat. So like that, if I give some finite set of labels to the model, so from these labels, what the model should do, it should pick an appropriate label and it should assign to this image. If you look at this, so most appropriate label will be man. So man will be assigned to this image, right? So that is what the process of image classification is. So when we give some image, from the finite set of labels, the model should be in a position to pick an appropriate label and it should assign that label to that particular image. In order to do that task, first thing is we need to provide experience to the model. right? So in a machine learning, that is very important. We should provide the experience. How we can provide the experience to the model or a computer? By providing it with data and labels. So we have a data and also its labels are available, right? Using this data and labels, what we are going to do? We are going to teach our model to learn, right? So how we should have this data label combination? We have to give as much as experience to our model. So we should have a huge data, right? In machine learning, we should have a huge data and labels together, right? This is first condition. Okay, we have to create a large experience, so we should have a large number of data to be collected. Second one is, even though I have large number of data, if it is monotonous in the sense similar data, it will not be of good use. In that case, what we should have? We should have a variety in the data. What do you mean by variety in the data? So for example, I want my model to do cat classification. I have a model, so I give some image, right? So it should give a prediction. Okay, let me keep the prediction as y hat, right? So let us assume this model needs to identify a cat in an image, right? If I give an image, this model should find cat, whether cat is available in the image or not. Based upon that, it should give a prediction, right? So if my model has learned how a cat is in a standing position, right? I have given some 1 million images for the model to learn. But the problem is I have shown only the image where the cat is standing. But when I deploy this model in a real-time scenario, what might happen? The cat might be running. The cat might be sitting, or the cat might be partially hidden, right? So there are different scenarios which our model has not learned, right? So what I should do with my data set is, we should have a variety in our data set. Variety in the sense, what are the things we should consider? We should consider different viewpoints. What is viewpoints? The cat or any object should be captured with different angles, right? On frontal face of a cat, I should have from side face, top view, back sides, all directions we should capture the object, right? So viewpoint, the data should have a viewpoint variation. Then the second thing which I should include is scale variation. Scale variation in the sense, the object should have different sizes. The cat I should capture as a small cat, old cat, medium cat. So like that, different scale variations. How a cat will look like when it is very close to the camera, how a cat will look like if it is far away from the camera. All this information should be collected while collecting a data set. Then the third one is deformation. Deformation in the sense, the cat will look different when it is sitting, when it is standing, when it is running, because its legs and all, it will be in a different position. Its head will be in a different position. So it will be getting deformed. So all the scenarios should be included in your data set. And the next one is lighting condition. So if I capture a cat under daylight, it will look different. If I capture under a night light, it will be different. With the fluorescent bulb, it will be different. So different lighting conditions also should be taken into account. And the next one is partial occlusion. Partial occlusion is, I can have a situation where the cat is hidden, partially hidden. The cat might be behind a tree, or it might be inside a bush, or it might be sitting on a tree. So there are scenarios where we have partial occlusion. So all these conditions should be included. Then we have something like an intra-class variation. So intra-class variation stands for, the cat can be in different shape, size, and colors, right? So for example, an African cat will look different. Indian cat will look different. New Zealand cat will look different. American cat will look different. So the cat, depending upon the geographical condition, it might be different. So those information, everything should be included while collecting your data set. So these are the important characteristics of collecting a data set. So while collecting a data set, two important things you should consider. One is, you should have a large data set you should collect, and this data set should not be monotonous, it should have a variety. So you should consider the viewpoint variation, scale variation, deformation, lighting conditions, partial occlusion, intra-class variations, all these things you should consider while collecting your data set. If you have collected a good data set, even a very simple algorithm can give very good result. But if your data set is very poor, whatever you do with your algorithm, you might not get good results. So our job will be almost 70% done once I have a good data set. So you should take utmost care in collecting the data set. In case of an IoT device, what will happen? Now my nodes is going to gather this data, right? And all this data is going to get acquired in our cloud environment, right? So if our node has less error, it is capturing more accurate data. If I use a very good sensor with a high resolution, then we will be getting a very good information. And with this information, when I apply a machine learning algorithm, it can give a very good result, right? So in terms of IoT, you should pretty much concentrate on your IoT device. So the IoT device which you design, it needs to be very good, so that the data which you get from an IoT device will be good. Then only when you put any machine learning algorithm, it can able to do much better way. So once I have collected the data set, the next step is splitting up the data set. Why we need to do that? Because we have to create an experience to the model, and also I need to evaluate the model, right? How well the model is learned, right? For giving experience to the model, we use training data set. For evaluating the model, we use test data set, right? So since I need to have a huge experience, our training data set will always be high when compared to your test data set. And this ratio between train and test needs to be fixed. There is no universal rule like 80-20 or 75-25 or 60-40. It varies from application to application. So whatever application you are working, so depending upon that application, what you have to do is you have to try out different ratios, and whichever ratio gives you better result, you have to stick on to that, right? So the train test split is the second step. Then once you split the data, right? So we need to train our model. We need to make the model to learn, right? So there are two ways in which I can make the model to learn. One is I can give the data directly to the model and make it to learn, right? So the complete data, the raw data, I can feed it to my model and I can make the model to learn. So this is one option. Second option is I can take the data, give it to some feature extractor. It will extract some features. It will extract some important information from the data, and that important information can be fed to your model to learn, right? So in two ways we can do this. One is I can give the raw data. From the raw data, our model will try to learn everything. It will try to understand everything about the data. Whereas in the second case, we use some feature extractors, so that what will happen? Important information, important features alone will be extracted, and from that we will try to teach the model, right? So here each technique has an advantage and a disadvantage. When I use a raw data, when I give a complete data, the computation time involved for training is going to be high, right? But since we are using the complete data, more information is given to the model, so thereby it gives very good result. But the training time is going to be high. When I use a feature extractor, what happens? We are extracting some information. We are not using the complete data. We are taking only the important information, right? From the important information, our model is going to train, or it is going to learn from it, right? So when I do that, the problem is, since we are not training it on the complete data, we are using only a small abstract of the data. It is not going to learn completely. So its prediction will be a little bit low. But the advantage is the training time will be very low, right? So again, how to decide? whether to use a raw data or a feature extraction, it depends upon your application. If your application requires good accuracy in prediction, in that case, you can go with the raw data. If your accuracy can be a little bit lower, but I should get the result at a faster rate, in that case, what you can do is you can go with the feature extracted data. Right? So depending upon your application, you please make a decision whether to use a raw data or to use a feature extracted data. So once you have made the model to learn, the next step is to evaluate the model. So how to evaluate? You give the test data. When I give the test data, I try to check how well the model is learned, whether I can use the model in a real-time scenario or not. So such aspects we can evaluate by providing the test data to the model. So these are the steps involved in machine learning for an image classification task. So let me repeat it one more time. So here we collect the data set, then split the data set into training data and test data. And using the training data, we try to train the model. And after training the model, we try to evaluate the model. Okay. Now let us talk about, since I have talked about the data set, so data set is very important for any machine learning algorithm. So the data set depends upon your IoT device. In an Internet of Things protocol, the IoT device is very important, right? So this device should give good data. Then only when I apply a machine learning algorithm or AI algorithm, it can able to work well. So what this IoT device is going to have, right? So this IoT device is going to have a processor, right? It is going to have a processor. So we should have a good CPU with good number of operations per second, and it should be able to support large bandwidth too. Either a 32-bit processor or a 64-bit processor, it is good enough, right? So it can take a huge amount of data and it can do processing and can give you a result at a faster rate. So a processor is required in an IoT device. So when I work with some image, okay, when we want to attach some camera and acquire some images, in that case, the CPU execution of the image will be very slow. So in order to speed up the process, we can use the graphics card, right? In graphics card, we will be having a graphical processing unit, right? So there will be a video RAM so that the images can be fed to the video RAM. From the video RAM, the GPU can take the data and it can process the data at a very faster rate. So an IoT device, if I have sensors, then we require a processor. If I have a camera, then we need to have a GPU system. Then we need to have some memory interfaces too. Some local memory can be there. Like I can use some NAND, NOR chips or RAM memories like DDR1, DDR2, DDR3, DDR4, DDR5. So like that, we can have different memory interfaces attached to the IoT device. And also we can have some external memories using storage interfaces. Like I can store the data in a SD card, MMC card, secure digital input output cards. We can able to store the data, right? So once, in order to process any information, I need to store the data, right? So this is a local memory, okay? Local memory to your IoT device. If I want to transfer this data to other node in a network, or I want to transfer this data into internet, right? So we will be having a connectivity. So connectivity, either the connectivity can be in terms of a USB host or using Ethernet, or we can use a Wi-Fi, WiMAX, etc. We can have a different connectivity and thereby we can send the data. If we want to work with some audio and video, then the corresponding interfaces are also required. If we want to have a video, in that case, HDMI support, RCA video. If we want to work with audio, then we can use a 3.5 mm audio jack. It can be connected to the device. If we want to connect some sensors and actuators, we can use different communication protocols. In addition to your I/O pins, GPIO pins, we can also use some communication protocols like UART, SPI, I2C. So this are all serial communication protocols. CAN protocol, it is widely used in your automobiles. and USB protocol through which we can connect sensors and actuators. So these are the different components should be there in your IoT device, right? So the performance of these components play a vital role in collecting a good data set, right? So you have to be very particular in selecting what type of processor you are going to have, what type of graphics card you are going to have, what type of memory you are going to have, what type of communication between the IoT devices you need to have, what type of connectivity. So everything plays a vital role while collecting a data set from an IoT device. Now let us talk about IoT protocols. So we have talked about a device, what the device should have, right? So now this device is going to gather the data and it is going to send the data to a cloud environment. And we are going to have an application which can be running on your mobile phone or in a computer through which we can access this cloud data, right? So this is done with the help of IoT protocols, right? So you might have known about a OSI layer, right? So here our IoT has 4 layers, which is link layer, network layer, transport layer, and application layer. So link layer is where we get the data from the IoT device. So here I will be having IoT device, right? So this IoT device might give the data using Ethernet. Another IoT device might be giving a data using WiMAX. So another IoT device might be giving a data in a Wi-Fi. So these are different communication protocols: Ethernet, WiMAX, Wi-Fi, low rate WPAN, cellular networks. So different IoT devices gathers the data and it can give the data in different protocol format. Okay, all these protocol formats are gathered in the link layer. Then once gathering, here the Ethernet packet will be different from that of WiMAX, and Wi-Fi will be different. So each and every communication protocol will have a different type of packet, right? So in order to store it in a cloud environment, what we have to do? We have to change everything into a common format. So that is done by your network layer, second layer. So in this layer, what happens? The data which we receive from IoT devices in different formats are connected or converted into a common format. So common format in the sense it is getting converted into a IP datagram packet. Okay, here we have a IP datagram packets. Once I have this IP datagram packet, I need to transmit this datagram packet to another device, or I need to send this packet to a cloud, or I need to send this packet to an application. So we need to do transportation. So that is done with the help of your transport layer. So once the data is transferred, right, when it is in cloud, we need to have some applications to access this data, right? So that is your application layer. So in application layer, either running on your mobile phone or a computer, through application, what we can do, we can access the data from an IoT device or from a cloud or from a network. Right? So that is what we will be having in your application layer. So IoT protocols, in the sense it has 4 layers. Link layer. So link layer gathers the data from your IoT device coming with different formats. In network layer, all this different format data gets converted into an IP datagram, and in transport layer, it gets transmitted and it reaches some other destination or cloud. And then using an application layer, we try to access this data. Now let us discuss one by one the layers. First, link layer. So link layer talks about how the data is physically sent. How the data is physically sent over the network's physical layer, right? So how the data is going to be acquired, how it is going to be sent, usually using a copper wire or coaxial cable or using some radio frequencies. So for example, if I take 802.3, which is an Ethernet protocol, right? So in network term, we will say it as 10 base 5 Ethernet, which uses coaxial cable. In case of 10 base T, we will be using Again, it is Ethernet, but now the communication channel is copper twisted pair cable. Right? If I talk about something like 10 base F, then we'll be using fiber optic connections. What is the difference? The data rate is going to be different. The coaxial cable data rate will be low when compared to copper twisted pair cable, and copper twisted pair cable data rate will be low when compared to your fiber optic connections. In fiber optic connections, we can have a data rate of about 10 gigabits per second. So it provides a data rate varying between 10 Mbps to 40 Gbps. Next protocol which we are going to talk about is Wi-Fi protocol, which is 802.11. Right? So here it is a collection of wireless local area network. So here if I talk about the standard 802.11a, it operates at 5 gigahertz band. 11b and 11g operate at 2.4 gigahertz band. Again, 11n operates at 2.4 or 5 gigahertz band. Again, what is different? The data rate is going to be different from one band to the another. So the provide data rates range is going to be between 1 Mbps to 6.75 Gbps. In case of 802.16 WiMAX, it is a collection of wireless broadband standards. It provides a data rate from 1.5 Mbps to 1 Gbps. In case of low rate wireless personal area networks, we can use this communication for creating a local area network. So mostly Zigbee allows a data rate of above 40 kbps to 250 kbps. If I require a low cost and low speed communication, we can make use of this low rate wireless personal area networks. Next, we have 2G, 3G or 4G mobile communications. Again, 2G means GSM and CDMA, 3G means UMTS and CDMA 2000, 4G means LTE. So again, what is the difference? The data rates are going to be different. For 2G, it is 9.6 kbps. For 4G, it is going to be 100 Mbps. So these are the different protocols through which the IoT device can send the data. Right? So now the devices are connected in a network. So one device gives the data in an Ethernet format, another device might be giving in a Wi-Fi format, another device might be giving in a low rate Zigbee networks. So like that, it comes in a different format, right? So it is very difficult for us to save all these formats in a network. So what we do is we need to convert all this different format data into a common format. So that is done with the help of a network layer. What the network layer is going to do? It is going to convert all this data in different formats into a IP data. And it provides the host addressing from where it is going to be originated, from where it is going to go. And packet routing, everything is going to be done in your network layer. Here the important thing is addressing will be done, packet routing will be done, but it will not ensure whether the packet has reached the destination or not. That is the role of your transport layer. Okay. So in network layer, we have two protocols. One is IP version 4 and IP version 6. When we talk about IP version 4, it's an internet protocol version 4, which is used to identify the devices in the network. Here they use a 32-bit address scheme. So how many devices we can connect? We can connect 2 power 32 devices. So even though this number looks large, in the year 2010 itself, this 2 power 32 addresses have run out, right? So what they have done is they have gone into a next version called as IP version 6. In IP version 6, each device will be allocated with a 128-bit address. So when I have 128-bit address, the total number of addresses which we can accommodate is 2 power 128 addresses. So currently we are using IP version 6 protocols. Then we have 6LoWPAN. So 6LoWPAN is a low power wireless personal area network. So the LoRa modules, you might have heard about the LoRa modules which operate with low power, and for long range communication we can make use of it. So usually it operates at 2.4 gigahertz frequency range and provides a data rate of 250 kilobits per second. So these are some of the protocols in your network layer. Then comes your transport layer. In transport layer, it is going to ensure proper delivery of your packet. Right? It will ensure that whether the packet is being delivered properly to the destination or not. So that is done with the help of your transport layer. So it ensures end-to-end message transfer capability. Right? So here we have two protocols. One is TCP, transmission control protocol. Another one is UDP, which is user-defined protocol. TCP control protocol is a handshaking protocol. Right? So it will ensure whether the packet has been reached in the destination or not. It will use some handshake signals, return signals. As soon as the packet is transmitted, it waits for the acknowledgement. Once the acknowledgement is received, then only it will try to send the next packet. Right? So such a protocol, we call it as a TCP protocol. So in our web browsers, when we type HTTP or HTTPS, we make use of this TCP protocol. Same way for sending emails, file transfer protocols, everything is a TCP protocol. So here, when I send the data from one place to another place, it requires an acknowledgement from the other side, whether the packet has received properly or not, or whether it has received without any errors. If it indicates some errors, then the packet will be resent again. Right? So that is what happens in your TCP protocol. Next comes your UDP protocol. In UDP protocol, which is a user-defined protocol, it's a connectionless protocol. So here there is no handshake signals. Right? Since I don't have a handshake signal, we can't send a big packet. If a big packet is lost in a network, then it will be a huge loss for us. Right? So what we do is we divide the packet into small packets, and each packet will be transmitted in a different path. In the destination, all the packets will try to reach, and then we try to combine all the packets to get the original data. Right? So here there is no handshake signals. So the advantage of this is even one packet is missing. Right? Even if, for example, I have a big packet, I'm dividing this big packet into some 100 small packets, and I send this 100 small packets through 100 different routes. In the destination, only 95 packets have reached. 5 packets, somewhere it has lost. Then with that 95 packets, we can able to reconstruct the information. If more packets are lost, then it is a problem. Right? If few packets gets lost in between, then there is no problem. We can able to recreate it. But the advantage here is it will be very fast. Right? In case of TCP, it waits for acknowledgement for each and every data. Right? So it will be a little bit slow. But here we are not going to worry about the data. We are going to send the data. So it will be sending at a very fast rate. And since we are not going to worry about the handshake signal, it will be able to do it in a very fast way. So for real-time streaming, we will be making use of this UDP packet. For example, we have live cricket matches going on. So this live cricket matches are being telecasted, right? So here, if 1 or 2 frames gets missed while transmitting, right? No problem with it. With the remaining frames, we can able to construct a video, right? We will not be able to see much difference in the quality of the video transmission. So such a protocol, we call it as a UDP protocol. So next comes your application layer. So application layer is where we build applications in your mobile phone or in a desktop computers. We try to use these applications for accessing the data in an IoT device or in a cloud environment, right? So we have different protocols like HTTP protocol. You might have known about HTTP protocol, which is hypertext transfer protocol, right? Which follows a request response model. I will come to this later. What is request response model? So mostly in our website, when we type www, it is nothing but a HTTP protocol, okay? Worldwide web. And each website will be identified by the URIs, Universal Resource Identifiers. Same way, other types of application layer protocols are available. Constrained application protocol for machine-to-machine interface. In an industry, if I have multiple machines, one machine should communicate with the other machine. So in order to have this machine-to-machine applications, we can make use of this OAuth protocol. So it also supports request response model. Then there is a WebSocket which supports full duplex communication. Full duplex in the sense both way communication. Transmission and reception can happen simultaneously. So that is the advantage of having a WebSocket based communication. Then we have MQTT, Message Queue Telemetry Transport Protocol, which works on a publish subscribe model. I will talk about this communications model. So it supports for messaging, right? For messaging, we try to make use of this MQTT protocol, and it is suited for constrained environments, right? If I have a local network, within that network, if I want to transfer the information through messages, we can easily do it with the help of a MQTT protocol. Then we have XMPP protocol, which is extensible messaging and presence protocol. If you want to do some real-time communication, real-time live streaming XML data, in that case, we can make use of this XMPP protocol. Then we have this data distribution service protocol, where we can have a centralized data, and this data can be given to any of the IoT device connected to it. So it can be a device-to-device communication or machine-to-machine communication. So it will be something like a data-centric middleware standard. So here also it makes use of publish subscribe model. Then we have AMQP, which is advanced message queuing protocol. It is for business messaging. When I want to broadcast the messages, I want to broadcast the messages to multiple people. In that case, we can make use of this AMQP protocol. It also supports publisher subscriber model. So these are the different IoT protocols in your application layer. So let me recap what are the IoT protocols. We have 4 layers: link layer, network layer, transport layer, and application layer. In link layer, IoT devices give data in different protocol formats. In network layer, all this data is collected and it is translated into a common IP datagram, and this IP packet is getting transmitted from source to destination, and it is ensured in your transport layer. And from our application layer, we try to access this data in an IoT node or in a cloud environment. Now let us talk about communication protocols. How data is being communicated from one device to another. So that is IoT communication models. So the first model which we are going to discuss is request response model. From the name itself, you know that request response. If a request comes, then there will be a response for that request. So the client sends request to the server. It requires some data from the server. So it makes a request. Client makes a request. And the server, what it does, it responds to the request. So this is called as a stateless communication model. So for example, here I have a client which sends a request to the server. It sends a request to the server. What the server will do, it receives the request from the client, process the request, and it identifies the resources, right? So it identifies the resource, prepares, and sends response to the client. From the resource, it takes the data, and it prepares and it sends the response to the client. So such a communication model is called as request response model, right? Where a request is made, and based upon the request, the service is provided. Okay, such a communication model is called as request response model. Next comes your publish subscribe model. So publish subscribe. So from the name itself, you can understand data providers will publish the data, right? So data providers are data generators. For example, IoT device can generate a lot of data. So that data, it will try to publish in the network, right? There will be some subscribers for that particular data, right? So that subscribers alone will be able to access the data provided in the network. Okay, such a model is called as publish subscriber models. So here it involves publishers, brokers, and consumers. So publishers are data generators. Okay, data generators are data providers, right? So they will generate the data or they will provide the data, right? Brokers are something like an intermediate, right? So they will collect this data, right? They will collect this data, and what they will do, whoever the consumer has subscribed for that data, the broker will try to send the data to the consumer. So here the publisher sends message to the topics, right? Whatever data it generates, it generates the message and it tries to send to the topic. For example, message 1 is published to topic 1, message 2 is published to topic 2, and there will be some subscribers for topic 1, there will be some subscribers for topic 2, right? So those subscribers will be able to access the relevant data. It is something like our newspaper, right? So we might have subscribed to Hindu, right? So the Hindu, they will create the newspaper, they are publishing the newspaper. As a subscriber, I am getting the Hindu newspaper, right? I will not get other information. Whatever Hindu is providing, that alone I will be getting. Some other person might be subscribed to some other Times of India or some other data provider, right? So they will get that information, right? So it is something similar to that of your newspaper generation and subscription, right? So it is called as a publish subscribe model. The third model is your push-pull model. So what is push-pull model? So here the data producers generate the data, right? IoT device, it will generate the data and it will push the data to the queues. Okay, after generating, it will try to put everything into a queue, like a memory, right? It will try to put it into a memory. And whoever requires the data, they will try to pull the data out of the queue. Okay, that is called as push-pull model, right? So the data generators, what they will do, as soon as they generate the data, they try to put it into a memory location. Then whoever wants the data, what they will do, they will try to extract the data from the memory, right? So that is called as a push-pull model. So why this model is very important? Because here the devices which require data might operate at different speeds, right? For example, the generator might generate the data very fastly, but the receiver will not be able to receive the data fastly. In that case, as the speed I'm going to generate the data, what I will do is I will put it into a memory location, right? The consumer, whoever wants the data, they will take the data depending upon their speed, right? So that is why this push-pull model is very popular. So here you can see the publisher generates the data and pushes this data into the queues. Okay, it pushes the data into the queues depending upon its speed. Okay, publisher speed, right? So they will publish at their speed. The consumers can take the data from queues on their own speed, right? So the speed mismatching will not be there, right? Since the publisher and consumer operates at different speeds, in between memory acts as a buffer. It helps in supporting this data transfer. So such a model is called as push-pull model. Then we have one more communication model called as exclusive pair model. So exclusive pair is a bidirectional model. So both way communication is possible, transmitting the data and also receiving the data. It supports fully duplex communication. Duplex communication in the sense transmission and reception can happen simultaneously, right? So this exclusive pair, if you see, there is a client, right? So the client and there is a server, right? So let us take the client to be an IoT device. Let us take the client to be an IoT device. So this client, what it can do is it can make a request for setting up the connection. Okay, I want some data, so you please establish the connection, like that it is making a request. What the server will do, it will respond to that request. After receiving the response, the connection will be established between the client and the server. Once the connection is established, what the IoT device can do, it can gather all the information and it can put it onto the server, right? So after passing on all the information, right? So the IoT device, what it can do is it can send a close request, right? So upon receiving the close request, the server can send the connection close response. Then the channel will be disconnected. Then whatever the data IoT device is generating, it will not be transferred to the server. Okay, so such a connection is called as exclusive pair connections. So here we talked about 4 communication models. One is request response model. So when a client needs a data, it will make a request. Upon receiving a request, the server will provide the response. Second one is publish subscribe model. In publish subscribe model, what happens? The data generators like IoT device, right? It will generate the data and it will publish it, right? Whoever wants it, okay? Whichever application wants some data, who are subscribed to the data, it will get the data. Or it can also be another IoT device which can access this data if it is subscribed to that particular data information. Such a model is called as publish subscribe model. Then we have push pull model. In push pull model, the data generators, what it will do? It will generate and it will put the data into the memory, and the consumers will take the data on its own speed. Then the last communication model is your exclusive pair model, which is a bidirectional model. So in this model, what happens in the sense? First, the connection request is sent. Then after receiving the response from the server, connection is established. After doing all the transactions, again, the close request is sent. And after getting the close response, then the channel will be disconnected. Because such a model is called as exclusive pair models. Next, we will talk about different IoT levels and deployment templates, right? So how a IoT system should be there, right? So we have 6 levels. Level 1, level 2, level 3 talks about single node. Level 4, level 5, level 6 talks about multi-nodes in an IoT system, right? So first I'm going to talk about level 1. So level 1 is a single node or device which performs sensing or actuation. It stores data and performs analysis and also hosts the application. Let us take, I have 2 regions. One is local, another one is cloud environment. In level 1, what we do is we make use of only the local environment, the IoT device. What the IoT device is going to do? It is going to gather all the information. Whatever sensors we have connected, it is going to gather all the information. Right? It will also do actuation. The IoT node will also do actuation if it is available. It will do some analysis also. Since I have a controller, it will perform an analysis on the data and it gets stored in a database, and we have an app to access this database, right? So everything happens on a local side in level 1, right? In cloud, we are not at all utilizing it in level 1, right? So a device does everything. It gathers the data, it actuates, all the information gets analyzed, and then the data gets stored in the locally itself, and then we have an app to access this database. So everything happens in a local side. So such a system example is home automation. In home automation, we can have a small controller board which senses different parameters in a home, right? And based upon the different parameters, it can also do actuation. Okay, switching on a device or switching off a device, it can do. So here, no need of sending the data to a cloud environment or into an internet, right? So everything happens locally. So such a system, we call it as IoT level 1 system. Let us move on to the next level, IoT level 2. In level 2, also we are going to talk about only single node. Okay, we are going to talk about only single node, one device. Single node means one device, one IoT device. So this device, what it is going to do, it is going to perform sensing or actuation, and also it will do local analysis. But after doing local analysis, what happens? The data is stored on the cloud side. That is very important. And the application which we built is going to access the data from the cloud side, right? So here I have a local side, here I have a cloud side. If you see, this is an IoT device. What this IoT device is going to do? it is going to gather the information. Since I have a controller here, right, it will also perform analysis on the data. But where is the storage? Storage is in the cloud side. In cloud, we try to store the data. And we have an application which is going to access the data from the cloud. Right? We are going to have an application which is going to access the data from the cloud. So such an application, we call it as IoT level 2. Example is smart irrigation system. Now let us talk about level 3. So level 3 is also for single node, right? So level 3 is also for single node. Here what it does, this is an IoT device. This IoT device, what it is going to do? It is going to gather the information, right? Even though it has a controller here, this controller is not going to do any analysis here, right? It is just going to gather the information, controller, and it is going to send to the cloud side. Send the data to the cloud side. Here in the cloud side, what happens? Storage and analysis takes place. Okay, both storage and analysis takes place, and we have an application which makes use of this data in the cloud side. So such a level is called as IoT level 3. So this level 1, level 2, level 3 is for single node, one IoT device. So level 1, what it is? Our IoT device is going to gather the data, actuate, and it is going to do processing on the local side, and the data will be stored on the local side. Application is going to make use of the data stored on the local side. In level 2, what happens? IoT device is going to gather the data, do some analysis on the local side, but where is the storage? Storage is in the cloud side. And application is going to make use of the data in the cloud side. In IoT level 3, we are going to have a device, single IoT device, which is going to acquire the data, actuate, but the processing is going to happen on the cloud side. Storage is also going to happen on the cloud side, and the application is going to access the data from the cloud side. So that is a level 3 IoT device. Now let us talk about multi-nodes, right? So in multi-nodes, we have 3 levels, that is level 4, level 5, and level 6. Level 4. So level 4 talks about multi-nodes that perform local analysis. So here I'm going to have multiple nodes, IoT node 1, node 2, node 3. So like that, I'm going to have multiple nodes, right? And this nodes, what it is going to do, each node is going to do some local analysis. Since it has a controller, each node will have a controller, it can do some local analysis. After analysis, what happens? The data is stored in the cloud. Okay, data is stored in the cloud, and the application is cloud-based. Right? So if you look at this in terms of a diagram, you will understand it better. Here you see, again, I have a local and a cloud side. In level 4, what happens? We have device 1, device 2, device 3. So like that, we have multiple devices. All these devices are connected to a sensors and actuators, right? And each device has a controller service. So with the help of this controller service, what it will do? It will acquire the data. It will also do some local analysis. After performing some local analysis, what can happen is this data goes into the cloud side where the data gets stored. Okay, in cloud side, the data gets stored. And the app which we use is going to make use of the data from the cloud side. Right? And since a lot of data is being acquired in the cloud side, we can have some intelligence also. We can run some machine learning algorithms here to the data which we acquire, and we try to do some predictions as well. So if you look at this local side and cloud side, you have observer nodes. So this observer nodes can subscribe to any other node, right? So in a publish subscribe model, okay, it can get subscribed to any other node, and it can also publish the data from this IoT devices. So from this IoT device, whatever the data it gathers, this observer node can publish it, right? If this observer node wants some data from some other observer node, it can gather the data, right? So that is the advantage of using your IoT level 4. Now let us talk about level 5. In level 5, we will be having multi-nodes again, multiple nodes. But here there will be a coordinator node. One coordinator node will be there. Right? When I have multiple nodes, out of that multiple nodes, one will act like a coordinator node. What is the role of this coordinator? It will collect all the information from the other nodes. It will collect all the data from the end nodes and send it to the cloud. Where the data is stored and analyzed in the cloud, right? And the application is going to use the data from the cloud, right? So mostly this type of network is applicable in your wireless sensor networks. So let us try to understand with the help of a diagram. So here you see, I have a local and a cloud, right? So in the local side, you can see there are many devices, device 1, device 2, device 3, like that. I have n number of devices. Out of that n number of devices, one device will act like a coordinator, right? What this endpoint devices will do, it will gather the information and it will send the information to the coordinator. Okay, all this data will go to the coordinator. What is the role of a coordinator? It will collect all the information from the nodes, then it will send the data to your cloud side. In cloud, the data can be stored. Since huge data is acquired, we can put some machine learning algorithms for prediction, and also we have the app to access the data in the cloud side. And here also you have the observer node similar to that of your level 4. Right? So this is level 5. Next, we will talk about level 6. So level 6 again, multiple nodes, multiple independent end nodes. It performs sensing and or actuation and send data to cloud. So data is stored in the cloud and application is cloud based. We will understand once you look at the diagram. Right? So in level 6, what we do? We have multiple nodes. Right? All these nodes, what it is going to do? It is going to gather the information or it is going to do some actuation. Right? The local analysis will not be done here. Right? Local analysis will not be done. All this data, acquired data, it will go to a centralized controller which is available in the cloud side. Okay, in cloud side, you have a centralized controller. It is not in the local side. All this data which gathered from the local side goes into the centralized controller in the cloud side. From the centralized controller, the data gets saved in the database and the app is going to access this data. Since huge amount of data is there, AI algorithms can be run on this data and we can do processing. So one important aspect is from the cloud, we can give instructions to the node. Okay, since I have a centralized controller here, so we can send some information to the nodes, so that by the nodes can get altered. Right? So that is possible in case of your level 6, but that is not possible in case of a level 4 or level 5. Right? Since I have centralized controller in level 6, we can send some commands to the IoT device. So thereby their functionality can be modified. Right? Their functionality can be, for example, if IoT device is measuring some 10 parameters, let us assume IoT device is measuring some 10 parameters, I can send a command from centralized controller that you measure only 5 data. In that case, what will happen? Then the IoT device will start measuring only 5 data. Other 5 data, it will be stopped. So like that, we can send some control commands to the IoT device in case of your IoT level 6. So level 4, level 5, level 6 is for multi-nodes. In level 4, what we do? We have multiple IoT devices. It gathers the data, actuates, and some local analysis is being done, and the data is sent for storage in the cloud side. We have an app built on the cloud side, thereby it accesses the data on the cloud, and in level 4, level 5, level 6, we can introduce the intelligence also by using some machine learning algorithms. In case of level 5, It is something like a wireless sensor network. In the local side, we have endpoint devices and there will be one coordinator node. All these endpoint devices, what it will do, it will send the information to the coordinator node. Coordinator node, what it will do is, in turn, it will send the data to the cloud for storage and analysis, and the application is going to make use of this cloud side data. In level 6, we have multiple devices in the local side. Here, the gathering and actuation will happen on the local side, but analysis, storage will happen on the cloud side. And intelligence is incorporated on the cloud side, and the app is going to access the data in the cloud side. One more important aspect is, in the cloud side, we have a centralized controller which can send the commands to the IoT device. So thereby the IoT device functionalities can be modified. So these are the different IoT levels and deployment templates. So once you start building your network, you have to think in which level you are going to design your system. So once you know that where to apply your machine learning algorithm, where I can put my machine learning algorithm or AI tools so that my IoT device can perform in a better way. So what are all the challenges in IoT deployment? One important challenge is you have to have multidisciplinary knowledge so that you can create your own IoT device and you can deploy it, right? So that is one aspect. In addition to that, we have other challenges like security. So our IoT devices should be compliant with some security policies. That is very important. Okay? So because these IoT devices, if it is manipulated, then it may result in some severe damages. And we should have an extended network infrastructure. Since we are going to connect multiple devices to the network, we should have a huge database. Large amount of data will be generated. So we should have a provision to store this data. We should have a provision to do some analysis on this data, right? So there will be more IP addresses, more data coming out of it. So we should have a very good IT infrastructure. So that becomes a very big challenge. The third challenge is onboarding of sensors or nodes. So when I have a huge network, if I want to add 1 or 2 nodes, I should not go there and I should configure the network. Automatically, it should get configured. So automated onboarding of sensors should happen. So this becomes a challenge. What will be automated onboarding of sensors? As soon as I connect a device, it should get recognized. And it should allocate it into an appropriate network, and governance should be enabled for those devices. So immediate onboarding should happen, right? So it should not take very long time to get on board or get connected to a network. So what are all the different AI methods which we can use for our IoT applications? So one thing I have talked about is classification part, right? So classification, when I have a data, right, I can classify the data, right? So either it is a spam data or non-spam data. If it is an image data, it can be classified as an animal, human being, or some object. We can able to classify it, okay, based upon the features or based upon the raw data. So classification or categorization is possible with the data which we acquire from IoT devices. We can also do some regression analysis. So regression is something like estimating a quantity, right? It is not like categorizing. Here we are going to estimate a quantity, right? From the data which we get from an IoT device, we should be in a position to make a prediction. What should be the temperature value after 1 month, right? So based upon the data which we acquire, so I should not just say that temperature is high or low. If it is high or low, it becomes a classification. I should be in a position to say that after 1 month or after 1 year, the same date, the temperature will be something like 28 degrees or 29 degrees. So I should have a real-time quantity as an output. Then we call it as a regression algorithms. So such algorithms can be applied to the data. Clustering of data is possible, right? When I have similar data, I can cluster it together and I can form it as some separate category. So these are some of the methods which we can apply onto your IoT applications. classification, regression, and clustering. Now let us talk about few applications, IoT applications. With that, we will wind up the session. So in IoT applications, first application which I'm going to take is smart city. So in smart city, we can have different aspects. Traffic management, right? So traffic management. So if I have congestion in one place, I can divert few vehicles to different path, right? So traffic management can be done. Air quality monitoring can be done. So if I have a polluted area, then what we can do is we can divert the transport to some other location where the air quality is good, so that in the current area also the air quality can become better, right? Public safety solutions, smart parking facilities, right? Where is the vacant space to park a vehicle and how to go to that vacant space, routing, tracking the location. So those things can be done in a smart parking. Smart lighting, energy consumption can be greatly reduced when we use smart lighting. Smart waste collection, right? So unnecessarily, if a vehicle is used for clearing the garbage, that will result in a huge fuel consumption. That can be minimized, right? So like this, we can do a lot of things in case of your smart cities. So in case of smart transportation, how the IoT is changing the transportation system? With improved customer services, dependable transportation, and accurate communication, it improves the traveler's experience. So we can have a smart roads. Smart roads will, in the sense, the roads can be incorporated with a lot of sensors. So thereby congestion, air pollution, everything can be identified. Based upon that, the traffic management can be done. Parking, bridge sensors to see the structural health, how well the bridge is going to behave. If I have more vehicles passing through the bridge, how much stress it incorporates into the bridge. We can make some reliability analysis, life cycle analysis of a bridge using some bridge sensors. Bicycle and pedestrian monitoring is possible. How many bicycles are being used? How many pedestrians are using the crossways? Micro navigation in public transportation. Airport and air travels can become smarter. Travel innovations, travel itineraries can be smarter. Security issues, minimizing the energy consumption. So like that, in smart transportation itself, we can able to do a lot of things. So in transportation, if I want to move from A to B, right, in an efficient manner, in a safety manner, what are all the different things we can do, right? Smart traffic solutions is possible. We can use different types of sensors like road surface sensors, CCTV cameras. We can fetch the GPS data from the driver's mobile phone, right? We can fetch the data from the vehicle itself, and we can determine the number, location, and speed of the vehicles. Thereby, the commutation will become much more easier. So we can monitor the green light timings, right? Depending upon the congestion in a road, the timing of green light, red light, and yellow light can be varied. Okay, it can be adjusted, right? So the historical data will also provide, right? So when the traffic will be high. For example, in case of some festivals, right? Temple festivals, in a particular zone, there will be heavy traffic. So when that particular festival comes, the traffic management can be effectively planned. So such scenarios we can use for smart transportation.
Yes. No.
Transportation. We can have a vehicle to vehicle communication is possible, right? So we have a lot of electronics in one vehicle. So those data can be communicated with each other so that smart transportation can be done. We can also do vehicle to infrastructure communication, right? So vehicle can communicate with the nearby infrastructure, something like a traffic light or nearby post, it can communicate. So thereby the traffic management can be in a much better way, it can be implemented. So vehicle to vehicle communication is possible. Vehicle to infrastructure communication is possible. Infrastructure to infrastructure communication is possible. And from this vehicle infrastructure, we can send the data to a central station also. So in case of air quality, we can identify the traffic jams. Depending upon that, we can alter the traffic lights and we can divert the traffic jams. So based upon the air quality also, we can adjust the traffic lights and we can reduce the air, or we can make the betterment of your air quality. Here in smart transportation, so the maintenance and control of street lamps can reduce the energy consumption, right? So it is by using the street lights in a smart way, we can reduce lot of energy consumption. So how we can do that? Here we can see that a smart lamp which has lot of gadgets embedded into it. So it has a weather sensors, anemometer, barometer, rain gauge. So many things can be embedded into the street light so that the weather monitoring can also be done. And it has a security camera, so it can be used as a surveillance camera, right? So it has a digital signage street, so it has a push to start button, emergency notification system, right? So there are different types of sensors like light sensor. So depending upon the ambient light, the intensity of this street light can be adjusted, right? So if I have a very dark environment, then the brightness of the LED bulb can be increased. If I have less darkness, then I can dim the light. Depending upon the number of passengers or persons crossing this street light, also we can either increase the brightness or decrease the brightness. So we can make a pedestrian count. After pedestrian count also, what we can do is we can able to adjust the street light, right? So such things can be incorporated. So a street light not only functions as a street light, it also acts like a weather station, it also acts like a pedestrian counter, it also acts like a surveillance camera. So a lot of different things are being incorporated into a street light. So next one is something like in smart transportation itself, we have toll collection, right? So nowadays automatic scanning of the codes happen in our vehicle and automatically the prices are being deducted. So automatic toll collection can happen. So with the help of different devices in parking also we can make use of it, right? So we can have a map which can route the driver towards the vacant parking space, right? So each parking space will have some sensors, right? So here you can see a sensor, right? So this sensor, if it is not activated, means no vehicle is being parked in this location. So automatically the driver will get the information and there will be an application which will try to route the driver towards that vacant parking space. So each parking space can be connected to a nearby station, thereby the information can be obtained in a global manner. So IoT sensors can help to reveal patterns of how citizens use transport, right? So in which route heavy crowds are being moving, right? So the sensors will help us to reveal the pattern, or in which season the crowd is going to be high. So those things we can able to easily identify with the help of IoT sensors. So it enhances the traveling experience and it ensures the higher level of safety and punctuality. So the ticket sales can be modified accordingly and the traffic information can be used for traffic management. So let us take another application in terms of environment, how it can be done. So to monitor the water quality, we can deploy different sensors across a water grid and connect them to cloud management system. If the water's pH level is high or if the amount of dissolved oxygen is high, in that case, we can give some intimation. If there is a leakage, that also it can be identified with the help of sensors. So one example is if a nitrate level exceeds some 1 milligram per liter in water, then we can give the alert to the maintenance team of contamination. Then the field workers can come there and they can try to rectify the issue. So in case of air quality monitoring, again, we can use different sensors, like we can measure the amount of CO, nitrogen, sulfur dioxide. So all this data can be entered into a cloud. We can do some analysis in the cloud. And once it reaches above certain level, what we can do is we can incorporate some precautionary measures, or we can point out some recommendations for the citizens. Then in utilities, we can have lot of beneficiary. So IoT equipped utilities can allow the citizen to save money. Something like smart meters and billing can be done. So smart connected meters can send data directly to the public utility over a telecom network. Okay, directly from smart meters, the data can be sent. So the companies can bill the consumer correctly, right? So this can be done for water, energy, and gas. So we can find the consumption patterns, in which month the power consumption is high, in which month the power consumption is low. So all this analysis can be done. Based upon that, our acquiring the power can be finalized. So utility companies can monitor the demand in real time and redirect the resources, right? If one particular area has a huge demand, if another area has a very less demand, they can take the power from that less demand area and they can provide it to a high demand area. So like that, appropriate planning can be done. So remote monitoring is possible. So in case of a smart lighting, nowadays there are devices, the lightings comes with some electronic gadgets incorporated into it. Thereby the data can be collected and it can be sent to a particular application. Then the data can be accessed using some application, either in a tablet, smartphone, or in a computers. Okay, so finally we come to the waste management system. So if I use a lorry, right, to collect the waste management, if I go to a particular location, if that bin is empty, then unnecessary fuel consumption takes place. So why can't we do it in a smarter way? Once we can incorporate some sensors into the bins, once the trash is full in the bin, then the sensor can provide the data to that management. Then the management can send the collecting vehicles so that the fuel consumption will be minimized and thereby more productivity can be applied. Right? So optimize the waste collecting schedules by tracking the waste levels, as well as provide route optimization and operational analytics. So by doing this waste management, we can achieve different things like reduction in the collection cost, no missed pickups, reduced overflows, waste generation analysis, in which area the waste generation is going to be high. So they can be taxed more. Right? So if a waste generation is low in a particular area, we can give some reward for that particular people. So like that, different government strategies can be incorporated. Right? CO2 emission reduction by reducing the fuel consumption for the vehicles. So like this, different scenarios can be built in. So finally, coming to healthcare. So in healthcare, by using IoT devices, we can limit the number of visits to the hospital clinics. Using telephones and text communications, we can minimize. So the doctors can monitor the patients from a remote area. So thereby they can give the recommendations whenever some abnormal condition or when some scenario goes bad. So they can able to continuously provide some solution for that scenario. So remote monitoring in the healthcare sector is possible. So increased patient engagement and satisfaction to the patient. The patient will know that, okay, doctor is with us all the time. So they will feel little bit confident. So their satisfaction will increase little bit by using the IoT devices. So there are different healthcare devices like watch, eyeglasses, hearing aids, activity tracker, detection system for identifying the fevers, smart watches, Google glasses. Then for hearing, we can use Fitbit monitor, scanner recorder. So like that, we have different healthcare gadgets are available. So IoT can be applied for different persons, like patients. We can have IoT, so they can use the wearables, so thereby their parameters, health parameters can be acquired, and this can be sent to the doctor. And depending upon those, the physicians can give their suggestions. So IoT also will help for physicians, right? So they can keep track of the patients much more effectively. So data collected from IoT devices can help the doctors to prescribe a proper treatment or proper medicine to the patients. So it also helps in hospital scenario. IoT helps in hospital scenario where we can put tags to different items like ventilators, defibrillators, nebulizers, oxygen pumps. We can add these IoT devices, so thereby we know in which area it is there, how frequently it is used, whether it is used heavily or not, or it is lying idle, so that we can do some real-time tracking of the equipments. Medical equipments is possible. So deployment of medical staffs at different locations is also possible. So IoT enabled hygiene monitoring devices help in preventing patients from getting affected, and asset management is possible, like for pharmacy inventory management, environmental monitoring, temperature, humidity control. So all these things are possible in terms of a hospital scenario. It also helps the health insurance companies to identify the fraudulent claims, and it provides a transparency between the insurer and the customers, and we can provide rewards for the customer if they have good physics, and if they try to maintain good physics, the insurance companies can give good rewards to that particular person. So thereby they will reduce the number of claims significantly. So I have come to the conclusion of this session. So here first I started talking about a definition of an IoT. So in definition of an IoT, I introduced few parameters like dynamic global network infrastructure with which supports different standard and interoperable communication protocols, and the IoT devices should be self-configuring, and these devices will have identity, attributes, and personalities, so that they seamlessly connect to the network environment. Then we talked about IoT device building blocks. What are all the components should be there in an IoT device, local node? Essentially, it comprises of CPU, GPU, memory interface, IO interface, and connectivity interface. Then we talked about IoT communication protocol, where we have IoT in terms of 4 layers: physical layer, network layer, transport layer, and application layer. Then we talked about communication models. In our communication models, we have 4 models. One is request response model, publish subscribe model, then push pull model, and exclusive pair model. Then we talked about deployment levels, 3 levels: level 1, level 2, level 3 for single node IoT deployment. Level 4, level 5, level 6 is for multi-node deployment. And we also discussed about IoT challenges. What are all the challenges we should address when we talk about IoT system, and how AI can support this IoT systems, how it can be used in the IoT framework. And finally, we talked about few applications in terms of transportation, healthcare, environment, etc. So with this, I will conclude my session. So if there are any queries, please let me know.